Antihydrogen has been dropped in a tall vacuum, and most of it fell down. So here is the question we must answer before we end. Does antihydrogen fall down? And if it does, where did the missing antimatter go? The strongest clue is simple to see on the instrument. More annihilation flashes appeared lower on the detector than higher. That breaks the easy anti-gravity idea. We know antihydrogen is neutral, so gravity can act cleanly. We do not yet know if there is any tiny twist still hiding. Strong magnets could fake gravity, but the apparatus cancels that and tests a tipping point. A quick payoff right now. The atoms drop when the magnetic grip is eased, and you can check it by the burst marks they leave when they vanish. The default story for many people was this: maybe antimatter falls up. If that were true, matter and antimatter could have peeled apart in the early universe, and the horror show of mutual destruction would have never happened. Two domains could have formed: matter here, antimatter out there. It is a neat fix for the missing half problem. The other default story among physicists is more strict. Gravity does not care what something is made of. The weak equivalence principle says all things fall the same way in the same field. Antihydrogen should fall down like a stone. These two stories cannot both be right. For years, contradictions to the first story were dismissed with one line: gravity is too weak to test on single particles, and stray electric and magnetic fields are far stronger. This was actually fair. Take a lone antiproton. The Earth's magnetic field pulls it about 100 trillion times harder than gravity does. Any drop test with charged antimatter is doomed. That excuse ended only when a new tool came online: neutral antimatter atoms held cold in a vacuum with magnets configured so we can tune their push as gently as a balance scale. Once that was built, the hand wave had to stop. The anchor contradiction is now in the data. In the Alpha-G apparatus at the European Organization for Nuclear Research, physicists made antihydrogen, cooled it close to absolute zero to slow it down, held it in a vertical magnetic trap, and then changed the fields to let it go. The atoms hit the walls and annihilated. That annihilation makes a spray of small particles which touch silicon sensors and record the place and time of their end. When the counts were sorted by height, a clear excess lit up the lower part of the cylinder. Roughly 80% of the released anti-atoms moved downward. The simple anti-gravity picture was not just weak. It was wrong in this setup. What would the old anti-gravity model predict here? It would predict a rise, a bias of events at the top, or at least a split with equal up and down if we miss something. What did we actually see? A clean downwards bias. What does that contradict? It contradicts the sign flip of gravitational mass for antimatter. The micro-reframe is crisp. Gravity still pulls on neutral antimatter the same way it pulls on matter. The reinforcement is not a vibe. It is a map of detector hits, and that map makes the reversal idea untenable for neutral antihydrogen under these conditions. This does not mean the test was casual. The team had to beat thermal motion first. An antiatom at room temperature flies like a tiny bullet. Gravity would be drowned by its random zigzag. So the group learned to cool antihydrogen with light, using lasers tuned to the right color to slow the atoms. Cooling pushed their speeds down so gravity could compete. That detail matters because it sets the instrument limit. If anything else were pushing, it would stand out once the atoms are this slow. The fact that dropping them gave a downwards result after careful cooling strengthens the case. What we saw was not noise, not drift. It was gravity. Another key test inside the same machine used magnetic fields like a balance scale. With the trap on, the anti-atoms levitate in a magnetic bowl. The team then tilted the bowl by changing the field strength top to bottom. Think of it like easing off your grip on a marble until gravity can nudge it over the lip. If anti-gravity were real, easing the top field would not send more atoms down. It would send them up. Instead, as the field slackened above, more atoms escaped downward and hit lower sensors. That behavior is the sign of a normal gravitational pull. The knob they turned gave a built-in cross-check. Now, let us talk about the annihilation itself, because it is one of the cleanest traces we have. When an antihydrogen atom touches normal matter, it disappears in a flash. The antiproton and the proton destroy each other and spawn a shower of short-lived particles that include pions, which is a family of small hadrons, and the positron meets an electron and throws off light. Silicon strips around the chamber trace the lines of these showers. Each line points back to a point on the wall. Those points draw the fall pattern. If gravity had been pushing anti-atoms upward, the shower map would have leaned the other way. It did not. The wall recorded a verdict. We should ask what this changes for the giant missing half mystery. If antimatter does not fall up, we cannot use gravity to sort the early universe into separate zones of matter and antimatter. That fantasy had a strong emotional pull because it was a single visual fix. It is gone. The stakes are high. The universe is almost all matter, with at most one tiny spare particle per billion that pushed matter ahead. Now, we must find the glitch elsewhere. That fact should deepen your sense of awe, not reduce it. Nature did not give us the easy way out. It hid the switch well below where gravity plays. Another loop, spectra matching. This is the study of color lines from atoms. Ordinary hydrogen has a famous set of sharp colors when its electron jumps between energy levels. Antihydrogen should have the same set if physics is symmetric. Precise tests already compared the two and found no difference within very tight limits. What would the old hope predict? If there were a big hidden difference in antimatter's inner structure, it would have shown up as shifted colors. Reality check. The colors line up. That again removes a whole class of easy answers. The micro reframe is that if antimatter is different, it is different by a hair thinner than these measurements have reached so far. Yet another loop locks onto mass and weight. The test in the vertical vacuum tube speaks to both inertial mass and gravitational mass of antihydrogen. Inertial mass is how hard it is to push something. Gravitational mass is how strong gravity pulls on it. The weak equivalence principle says they are the same thing. If antimatter had a mismatch, the fall would have shown an odd curve or an odd speed when the field was changed. The observed fall fits a world where inertial and gravitational masses of antihydrogen match within the current sensitivity. So, the anti-gravity dodge does not just fail. On direction. It fails in the deeper identity between how antimatter resists push and how it feels pull. A different path looks outward to space. If the cosmos had great zones of antimatter, the borders where matter meets antimatter would be lit up by the hard light of annihilation. Gamma-ray telescopes have hunted for such telltale edges at galaxy and cluster scales. If the old separation idea were true, we should see clean lines or patches of these lights. We do not. The sky is quiet in that pattern. That absence is itself a piece of data. It says that there are not large domains of antimatter hiding just beyond our reach. That reality check adds weight to the new drop result. If gravity is not sorting antimatter away on Earth, and the sky does not show it sorted away on cosmic scales, the separation escape hatch is closed, both in the lab and in the heavens. Back in the lab, there is a nasty confound we must control for. Even neutral atoms have magnetic moments, which means they still feel magnets a little bit. If the trap or the Earth's field shoved harder than gravity, we could be fooled. That is why the alpha G design is a tall cylinder with a symmetric set of coils. Researchers can reverse and vary fields to see if the pattern follows magnet settings or follows the vertical pull. They also map the Earth's background field and add compensation coils. When they ran these checks, the downwards bias stayed put. This matters because it slams the door on a cheap alternative explanation. The team forced the instrument to prove that the direction came from gravity, not a hidden push. We can add temperature as a second confound that had to be killed. Warm antiatoms wander. Their random motion would smear the result and could fake an equal up and down result even if gravity had a preference. Cooling by laser is the way out. A laser tuned to the right color nibbles at the antiatom's energy, acting like a tiny hand that slows motion without touching. When the team applied this and lowered the thermal speed, the gravity signal became readable. That is a textbook case of defeating a hidden variable. The result is not a surprise only because the method was exact. Let us pause and look at the engineering logic that let them read a force as weak as gravity on a single atom scale. Gravity is the weakest force we know. It loses to electric forces by a laughable amount in this regime. That is why the experiment depends on neutrality, cooling, vacuum, and the ability to dial the magnetic field like a seesaw. Each part trims off a source of noise. The vacuum prevents bumps from air. Neutrality cancels electric pulls. Cooling cuts the speed. Dialing the magnet gives a repeatable way to let gravity win. The whole chain has to hold for the message to be clear. When it held, downwards won. So, what did this test not do? It did not measure the fall to many decimal places. It did not read a perfect value for gravity's strength on antihydrogen. The sensitivity is not at the 1% level yet, though a new round of laser cooling is pushing toward that mark. That means very small effects, if they exist, could still be hiding. But the headline claim does not need sub-percent precision. A sign flip is a big effect. A strong up bias would have been obvious even with a coarser tool. That simple point is why the verdict about anti-gravity in this context is so powerful. Weak tests can still slap down big fantasies. Now, zoom out to the cosmic imbalance again. If gravity is not the escape route, where do we look? We look at tiny differences in how particles and antiparticles decay and oscillate. Some hints already exist in the way certain mesons change identity, and in the way weak nuclear forces treat matter and antimatter slightly differently. But those known effects are too small by orders of magnitude to explain why there is one extra matter particle per billion. The search must push to new systems. Antihydrogen is part of this hunt because you can test its spectra and its response to fields with ever finer precision. If a tiny crack exists, exact tools will find it. That is not a shrug. It is a plan. There is also a quiet piece of evidence from the absence of strange light near us. If our part of the Milky Way had pockets of antimatter stars, their gas would mix with ours and sparkle with annihilation light and gamma rays. Instruments that see these hard photons have not found the pattern you would expect from a nearby antimatter cloud. Combine that with the lab result, and the case gets tighter. Separation did not happen here, and it does not seem to happen out there. The missing half was not tucked into a safe room in the sky. That deepens the reverence. The answer will not be a picture. It will be a hidden rule. Consider the social reason why many people did not know this was even testable. For decades, antimatter was made in such small amounts and moved so fast that gravity tests were science fiction. Most physics coverage focused on smashing beams and counting shards, not on gently holding antiatoms in a bottle. The new path needs patience and craft. It takes a dedicated factory to make antiprotons, devices to slow them down, and traps to combine them with positrons. It then takes stillness that only lasers can make. There is no villain behind the gap in awareness. It is just that the signal was below our reach until very recently. Now, with this drop test, the signal has crossed a threshold you can feel. We can now state the title question clearly and answer it step by step. Does antihydrogen fall down? And if it does, where did the missing antimatter go? The verdict on the first part is yes. When released in a vertical vacuum and tracked by annihilation flashes, antihydrogen falls down. That observation eliminates the old idea that a simple sign flip in gravity separates antimatter from matter. It rules out anti-gravity for neutral antihydrogen at this scale. What remains unexplained is the cosmic matter surplus. Gravity does not account for it in this way. The strongest mechanism, supported by the new data, is that the weak equivalence principle holds for neutral antimatter to the current precision. The interpretation that stays open is that there may be very tiny differences in other forces or in dynamics that are still below our sensitivity. That is not a theory pitch. It is the boundary the evidence sets. What does this verdict change for you? It breaks a surface-level story and replaces it with a truer one. You cannot lean on gravity to tell a myth about antimatter rising away. Instead, you see a hidden mechanism world where 1 in a billion nudges in decay odds or in subtle symmetries tilted the early universe. Gravity, the weakest of the 4 known forces, bowed out of the mystery here. General relativity took a test and kept standing. The standard model of particle physics survived another round of checks from spectra and mass behavior. And yet, a hole remains at the center of our map. That hole should not make you cynical. It should make you respectful. The universe is stingy with the switches that shape everything. Let us deepen the picture with one more instrument detail that shows the care at work. The tall cylinder of the alpha G setup was not an accident. Gravity points down on Earth, so building tall lets the team stretch the small vertical drift into a measurable path length. The magnetic trap was intentionally made slightly weaker at the bottom when they wanted to test the balance, so gravity had a fighting chance to steal atoms away there. In one mode, the team even watched a kind of atomic levitation, where magnets held antiatoms at a known height until the field was tuned past a threshold. Crossing that threshold turned the cloud into a rain. That threshold is a fingerprint of the pull of gravity balanced against the magnetic push. A fingerprint like that is hard to fake. Here is another way we know the result is real. If a stray push were tricking us, the team's reversals of field direction would have reversed the outcome. But the lower detector kept lighting up more when the release conditions were met, regardless of those flips. That kind of control experiment is what makes the conclusion feel unavoidable rather than pretty. The chain does not rely on trust in a single software fit. It relies on several knobs that all agree gravity points down for antihydrogen. Because this is a beginning and not an end, we can map the next steps. Better laser cooling will freeze the antiatoms even closer to stillness. That opens the door to 1% precision and measuring the exact rate of fall. With that, scientists can test whether there is even the tiniest mismatch between inertial and gravitational mass for antimatter, or between how it responds to the slight change in gravity with height. A null result would tighten the noose on speculative models. A non-zero result would be a shock. Either way, the data will narrow our choices. The search for the glitch will also branch into how antiatoms rotate, how they shift under microwaves, and how they respond to tiny fields. These are not random tasks. They are chosen because small cracks can hide there. We should also emphasize how hard-won this drop was. Making antihydrogen requires putting a negative antiproton and a positive positron together in the dark, all while never letting them touch ordinary matter. A magnetic bottle holds them. If the antiatom drifts to the wall, it blows up in light and particles and is gone. Every second, the apparatus is playing keep away at the smallest scale. The success is not an accident. It is the product of building an antimatter factory that can feed this work step by careful step. The factory is not a secret. It is a line of machines that slow, trap, and hand off bundles of this rare stuff so it can be studied like any normal material. Let us close the loop on the cosmic absence with one last reality check that connects lab to sky. If antimatter had its own gravity sign in rows, stars and gas clouds made of antimatter would float from matter zones even in mixed regions. Edges would look unstable and bright with constant annihilation. The lack of those lights agrees with the downwards fall seen in the lab. Two different instruments, two very different scales, same message. Gravity does not split the world by matter type. What is missing must have gone missing for another reason, likely in the first split second after the Big Bang, through events that favored matter by a microscopic tilt. The picture we are left with is sharp. The old explanation that antimatter could float away and explain the lopsided universe cannot account for the results. The hidden mechanism, whatever it is, lies in tinier differences, not in a reversed pull of weight. The drop test did not make the universe less strange. It made it more precise. That is what advances in physics often feel like. A door closes with a firm click, and the hallway ahead becomes darker, yet more focused. So, does antihydrogen fall down? And if it does, where did the missing antimatter go? Yes, antihydrogen falls down. The evidence eliminates a gravitational sign flip as the cause of the matter-antimatter imbalance. The result still leaves unexplained how matter won by a hair in the early universe. The strongest mechanism standing is the weak equivalence principle extended to neutral antimatter. What remains open is the hunt for faint symmetry breaks and minute dynamical effects that today's tools are only starting to see. That is the clean, forced conclusion. If you feel a quiet reverence right now, that is right. We have watched the simplest dream crumble and a deeper map come into view. The floor under antimatter is the same as ours. The mystery moved, not vanished. If you want to be here when the next decimal place forces the next change, stay with us as we follow each new instrument and each new trace. The universe rewards patience with clarity.